So this is Pascal's principle, right? A confined fluid transmits an external pressure. Pascal's principle, I think, also says that if you've got a fluid presses at right angles to the walls of its containers. So this fluid is going to press this way, this way, this way on all these walls, right? It always pushes at right angles to this wall, and it pushes with the same pressure everywhere. Now, I know that there's like some hydrostatic pressure difference, so the pressure here might be a bit less than the pressure there. We're going to kind of ignore that or keep our input piston and the output piston at the same level here. Okay. Now, if the pressure is the same in a body of fluid, right, like this, like a hydraulic system, okay, then what we can say, since pressure is force divided by area, if we have a situation where we've got different areas, we can generate different forces, okay? So for example, if I want to lift a car, I can have a very small cylinder here and push on that, right, with some input force, and over a much larger area, I could get a much bigger force. And the way that works is, of course, I'll have to push this thing up and down, maybe 1,000 times to move this thing up an inch, right? And so I'm exerting a smaller force over a larger distance because I have to keep going up and down, keep pumping this fluid, right? Okay. And that exerts a larger force over a smaller distance. Ultimately, that's what it is, right? And most mechanical advantage works that way, right? Or I guess all of it works that way, right? You exert a smaller force over a larger distance and get a large force over a small distance. Ultimately, though, it works out to this formula, right, where you get some force divided by an area is force divided by area, which is just pressure equals pressure. Okay. This is a diagram of what happens in the brakes. This is called the master cylinder, right? By the way, these cylinders used to be called slave cylinders. Thankfully, they're not calling them slave cylinders. Okay, but so the master cylinder exerts creates a pressure in this hydraulic system, and then that pushes on the brake pads. This is called the caliper, right? This is the rotor of the disc brakes, right? Let's do a problem here. So this hydraulic jack has an input piston. This is a small piston, right? It's about 8.2 millimeters, so less than a centimeter across, right? And then the output piston is almost, 10 centimeters across, almost, right? 100 millimeters would be 10 centimeters. What force in newtons do you have to apply to lift a ton? And a ton of weight is 8,900 newtons, right? So I guess this is we'll call this force out, right? So force out is 8,900 newtons. And then force in is what we're trying to find out. And then area, this input area here, that's the diameter, right? So this radius is 4.2 millimeters. Right? Now, by the way, if you mess this up, sometimes you can get the right answer. I'll show you why. Okay, so that is 0.0042 meters, right? That's our radius, our input radius, right? So I took half of this, divide by 1,000, right? Okay, oh, whoops, 4.1. 4.1, there we go, good eye. All right, so this area, if it's a circle, right, is going to be pi times 0.0041 squared. This is just pi r squared, right? And then the output is over pi times, let's see, 90. What's half of 95? This is too hard. 95 divided by 2 is 47.5, right? So it's is that 0.0475 meters squared? Let's divide that by 1,000. Yes, I did that right. Okay, so now we go. So basically what we're doing is we're saying that force over area is force over area, right? The pressure here is the same as the pressure here, but because the area here is bigger, we get a bigger force, right? Because the area here is smaller, we can use a smaller force to create that pressure, okay? And then notice that the pi's cancel out, right? Even the fact that we took the radiuses and cut them or the diameters and cut them in half, that also cancels, by the way. All right, so let's see. I'm going to go 8,900 divided by 0.0475 squared times 0.0041 squared. I'm just getting what F is. And I get that it's like 66, the input force is 66.6 newtons. right? What is that pressure in pascals? Okay, so I guess I can just go force divided by area, right? So 66.3 newtons divided by that area, so pi times 0.0041 squared. So I'm going to divide that by parentheses, pi times 0.0041 squared. And I've got, wow, that's a big number. 125,5604.648. So let's see, 1, 2, 3, 4, 5, 6. There we go. So that times 10 to the 6th. That's pascals, right? Remember, just an atmosphere is 1.013 times 10 to the 5th. So that's like 10 atmospheres, a little more, 12 atmospheres or something like that. And then how far must you move the input cylinder to raise the car 10 centimeters, right? Let's use conservation of energy to do that, right? So the work in has to equal the work out, right? So force times distance input has to equal force times distance output. So 66.3 times x, that's how far we're going to have, or d, right? How far we have to move it, right? Is going to equal 8,900. There's another way to do this, but this is the best way, times 10 centimeters, right? Okay, so 8,900 times 10 divided by that 66.3 number is 1342 centimeters, right? Now, most cylinders, of course, are not going to be they're not going to be 13 meters long, right? So what they do is they have a little check valve, and you just move it up and down until you've moved it down 13 meters, right? Which could be quite a lot. But remember, you're raising a ton. Okay, so yeah, there you go.